Hello everyone. Now we will study X-ray filtration and collimation. We have seen the X-ray machine. We know this is an X-ray tube, and inside these X-ray tubes, X-rays are produced. When X-rays are produced, they come out through a window, and once they come out through the window, we will have a filter over here and collimator over here. And now we will study about this filter and collimator system. First, starting with the filtration. Like we have studied before, this was the X-ray spectrum. If the X-ray unfiltered X-ray beam will have a large number of low energy photons, and the problem with this low energy photon is that they deposit and absorb in the patient skin surface, and they don't reach the film or contribute towards the image. So ultimately this will be harmful for the patient, as it will cause superficial skin exposure, and it has no role in image production. And so filtration removes this low energy photons before they reach the skin surface, and ultimately reduces the patient dose while hardly affecting the radiation that are producing the image. Since filter selectively absorbs the low energy photons, and remaining photons will have higher average energy. So ultimately filtration will decrease the quantity of the X-ray beam and increases the quality of the X-ray beam. Increasing the quality of X-ray beam or increase the high average energy of the X-ray beam is called as hardening the beam. The process of filtration mainly occurs through the photoelectric effect, and the likelihood of photoelectric effect is inversely related to energy. That is, likelihood of photoelectric effect is more for lower energy radiation and less for higher energy radiation. Coming to the types of filtration, we can have inherent filtration and added filtration, which will combine to form a total filtration. Inherent filtration means the filtration which occurs within the X-ray machine itself, and like this will basically means when X-ray hit the target material or the glass envelope or the surrounding insulating oil or the window or the this collimator system. So this all means inherent filtration. But additive filtration means that we will add one more uniform flat sheet of metal between this X-ray tube and the patient, and which will act as filter, and this is called as additive filtration. Additive filtration, this metal could be aluminium. Atomic number of aluminium is 13, and aluminium is generally used for low energy radiation, and most of the diagnostic X-ray beams may we use aluminium only, while for higher energy radiation like higher kV values we use copper, atomic number 29. So for higher energy radiation we use copper, whereas low energy radiation we use aluminium. Molybdenum and palladium filters have absorption edges, and thus they are favorable for mammography. The problem with copper filter is that the copper filter cannot be used alone, and they are used in what we call as a compound filter. Means once we use copper filter, na, they will emit a 9 kilo electron volt characteristic X-rays, and if this characteristic X-rays reach the patient's skin surface, then they will increase the skin dose. So to prevent that, we will also have a backing filter of aluminium with copper, and this is called as a compound filter. So aluminium we use mainly for lower energy radiation and most of the diagnostic X-rays, whereas for higher kV we use copper, and we use copper compound filter when it's backed up with aluminium. And inherent filtration is measured in the aluminum equivalent, that is the thickness of aluminium that would produce the same degree of attenuation as the inherent filtration. So typically inherent filtration is 0.5 to 1 millimeter aluminum equivalent. So advantage of filtration, I have told before, it will decrease the quantity and increase the quality or harden the beam. The one disadvantage advantage with this is, as it decreases the quantity of X-rays, so to compensate for it we have to increase the exposure time, which may increase the movement artifacts. Again telling, if we are using below 50 kVp, we need total filtration of 0.5. If 50 to 70, 1.5, and above 70 we use 2.5 mm aluminum equivalents. So coming to the compensation filters, the compensation filters may be attached to a tube to make the exposure across the film more uniform and compensate for large difference in transmission. Like this is a wedge filter, these are wedges filters, or this is a wedge filter, truck filters, or we can have, this is a boomerang filter. So we can have different kind of filters also. These are compensation filters. Next, coming to the collimation. Now we have seen this was our X-ray tube, and inside the X-ray tube X-rays were produced and they came out with the help of a window. From a window X-ray came out, And when X-rays were coming, we put one added metal material, that is a filter material, so that we can reduce the low energy, we can absorb the low energy photons. Once they come out, we have something over here, that is the collimator cyst. If we will see from the patient point of view, we will see two parallel metal sheet, and these are lead metal sheets like this and this orientation, and we can move them apart or towards, so that we can increase or decrease this rectangular space in between. And this rectangular space is the area from which X-ray beam will come out. We can reduce this, so we can reduce the X-ray beam which will come out, so we can. And further, we have something called as a light bulb over here, and light bulb will act on a mirror over here, and this will produce a light. And the function of this light is that we can know where our X-ray beam will hit. So advantage of X-ray collimator is that it will guide the path of the X-ray field, it will decrease the patient dose, it will also decrease the anodal effect, this will decrease the scatter radiation also, and ultimately increase the image contrast. So these are the advantages of X-ray collimation. Now let's revise. Filtration increases the skin entry dose. That is a false statement. Filtration does not increase the skin entry dose, it will decrease the skin entry dose. Filtration decreases the maximum energy of the photon, it will not decrease the maximum energy, it will absorb the low energy photons, so it will ultimately increase the mean energy. The next one, it will decrease the mean energy, that is also false, it will increase the mean energy of the X-ray spectrum. Filtration hardens the X-ray beam, that is true, it will increase the quality or hardens the X-ray beam. Filtration mainly occurs through the process of photoelectric effect. Copper is more efficient than aluminum in filtering high energy radiation, that is a true statement. Copper can be used independently, that is a false statement. We use something called as a compound filter, which we have copper with backed up aluminium. For general diagnostic radiology, total filtration should be at least 1 mm aluminum equivalent. If for general diagnostic radiology more than 70 kilo electron volt kVp, we use 2.5 mm aluminum equivalent. For 50 to 70 kVp, we use 1.5, and if it's less than 50, then we use 0.5 aluminum equivalent. So this is also false. Collimation allows operator to adjust the filtration of the X-ray beam. False. It will not have any relation with filtration, so that will false. Collimation does not affect the radiation dose to patient. False. With collimation, we reduce the volume of tissue which is being irradiated, and thus it will reduce the patient dose. Collimation employs a light beam diaphragm, that is a true statement. Collimators are constructed of matter that is highly attenuated to X-rays, that is also true. Collimation reduces the scattered radiation, that is also true statement. So this was the topic of filter and collimation. Thank you very much.